right, so the first thing is, what is a vector? All right, a vector is any quantity that depends on direction. Okay, so what does that mean? That means depending on what direction, the value may change. All right, a good example of a vector is force. Okay, force, you can either force something to the right or to the left or east or west or up or down, or in the positive x or in the negative y, things like that. So when you have a force, it has to have a direction to it so you can tell what it's going to do to the object, how it's going to change the object. All right, so you might say that you have 80 pounds of force east. Okay, that's an example of a vector because if I change this to west, it's going to change what this force does to the object it's acting on. Okay, so it's important that you have that. So that has the direction, and the value that you normally would think of as the force is what's called the magnitude. Okay, now often you see forces, not forces, you see vectors written slightly different. Okay, if you were to write force, which is capital F, the vector force has a arrow above it. That's how you would recognize that something is a vector, has a little arrow to show direction. Okay, sometimes in your book or in online text and things like that, they boldface it rather than using the arrow. Okay, so keep that in mind. If you see something that's got this arrow above it, that denotes a vector, which means it has a direction and is dependent upon it. Okay, now the opposite of a vector is what's called a scalar. Okay, so a scalar is magnitude only. Okay, the direction doesn't matter. So a good example of that is time. Time goes on no matter what is going on in a space or in a certain area. Okay, so whether you run to the left or you run to the right, 10 minutes is 10 minutes. Okay, you don't run to the right for 10 minutes in the same way and then run to the left and have it be 8 minutes. Okay, mass is another one. Okay, so mass is like a lowercase m, and you could be 80 kilograms of mass, the amount of matter that makes you up. That doesn't change depending on what direction you're going in. You don't get bigger if you go to the right. Okay, so if you notice, mass has the direction on the end absent, and it also doesn't have the arrow above it. Okay, so we're going to hit some different vectors throughout the year: momentum, force, some other things like that. Some things that aren't vectors are temperature, volume, mass, time, length. Okay. Things like that. So you need to get these two squared away in your head, all right, because you will have to be able to identify things as vector scalars and compare the two values at some point this year or multiple times throughout the year and next year. All right, so the reason why I wanted to go over a little bit with you today is because you have to be able to add vectors. Okay, vectors, they add together differently just because of that direction. Doing vector addition, all right, you have to identify the direction in your math. Okay, now you can't just put east in there because that doesn't make sense. You have to use some mathematical expression or what I'm looking for, mathematical identity to show that you have direction to something and that things have opposite direction. All right, now typically in math class, you learn about how the positive x is the opposite of the negative x. The positive y is the opposite of the negative y. Okay? Now, if you think about this, this looks very much like a compass, where this is north, east, south, and west. So typically, you could identify east as a positive x. You could identify south as a negative y, and so on. All right? That doesn't have to be true. You can identify any direction you want as positive as long as you make the opposite direction, the negative. So I could make south positive as long as I make north negative, okay? But typically this is what you go with just to keep things straight because these match up so well. All right, so let's say we had two vectors. A, which is 10 meters east, and B, which is 6 meters west. Okay, and I want them to add together to get what's called my resultant, or my final answer of C. So C is the resultant. Okay, I can't put in this in my calculator. It won't understand it. Okay, so this doesn't work. But if I know that east I'm saying is positive and west is negative, then I can add them together differently to get C, which I end up with positive 4, and because it's positive, it's east. Okay, so if I were to add together A and B to get my resultant C, I have to use negatives and positives to show opposite directions. Okay, so what you should get out of that is you should understand the role of positive and negatives in adding vectors. Okay, you see that when I wrote vectors down, I had the arrows above them. All right, I have negatives in my work, and I can't use the directions directly in it, because if you think about it, if you type in an east and west in your calculator, or an E and a W, it doesn't understand it. Okay, it's going to see them as variables. All right, now let's try one that's a little different. Let's say I had D, which is 5 meters east, and I had E, which is 5 meters north. Okay, and I want to add them together to get F. Okay, now look at them. These are not opposite one another. Okay, east is not opposing the north. All right, so that changes how we do it. We're going to have to look at how each one of them acts in the x direction and the y direction, and we can only add those together. You can only add x's together, and you can only add y's together. Okay, so really, this equation means two things. It means I got to add my dx value together and my ex value together to get fx. And likewise, I got to do dy and ey to get fy. And then once I have the parts or the components of f, then I can put them together to get my final. Okay? Because if you want to visualize it, which you should get comfortable at some point with drawing a vector diagram. Okay? Really, this is what we have. Here's my starting point, 0, 0. D goes 5 meters east. Okay. E goes 5 meters north. Okay, so this would be D. All right. This is E. F is the addition of the two, okay? The straight line distance from the beginning of D to the end of E. That's what you're trying to find when you find F. All right, so you're really trying to find F, which would be how those two go together to make that. Okay, so that is ultimately what you're looking for. How can you take these two out and put one in its place to end up at the same ending point? Okay? That's your goal. Now, if you look at that, what did we just make? We made a right triangle. All right? So if you recognize one like this that has a right triangle in it, it's just Pythagorean theorem to find F, which is something you learn in geometry, okay, and Algebra 1. But let's say it wasn't, and we want to go about the method of adding vectors together that works every time. Okay? You want to look at the x and y components of each. All right? I like doing these in a chart. Okay, an addition chart, just like you learn in elementary school. So what you're trying to do is you're trying to take D and E and add them together to get F. And because you can only add like parts, okay, you have to look at how the x's and the y's line up. So let's look at this. When you have D is 5 meters east. So if you look at your arrow that you've drawn, your x value is 5, and because there's no indication of north or south in this one, there's no y to that. When you look at E has nothing east or west, but has 5 north. Now you can add together what their values are, just like are written here in these equations. You end up with 5 and 5. So that means that your F vector has a value of 5 in the x and 5 in the y. Okay? But you don't express your answer that way. You want to express your answer as a length and a direction. Length and a direction. Length and a direction. Okay? So, how would I do that? All right. This is the method that you'd use every time. You just found the legs of a right triangle because you found 2 legs of a triangle that are perpendicular to one another. So anytime you do that, you do Pythagorean theorem. Okay, so the value of x is going to be fx squared plus fy squared. Okay, which is 5 squared plus 5 squared. Okay, which is the square root of 50. Okay, I'm going to leave it like that for right now just because I don't have a calculator in front of me, but you could multiply this out and get a decimal, all right, and have 1 sig fig in it because you only have 1 sig fig here, all right? So your magnitude for f, the length of this arrow right here, is the square root of 50. Square root of 50 meters, okay? But we're missing something. We're missing the direction, all right? And when you write a direction, you want to be specific. How many degrees is f? How far is f from the east-west line? Okay, so you want to line up how far do I have to go off the east-west line for me to do f, all right? That involves trig, okay? So if you look at it, you have 5 and 5, you have this component here. So we just found that this is 5 and this is 5 for our big right triangle, all right? You have to this angle theta, okay, theta is a 0 with a line through it. It's just a variable, okay? To the angle theta, you have the opposite side and you have the adjacent side, okay? Which trig function uses opposite and adjacent? It'd be the tangent. So the tangent of theta equals 5 over 5, okay? Since you're looking for theta, you gotta get theta by itself. You take the tangent -1 of both sides, and you get the tangent of -1 of 5 over 5, okay? And that comes out to be 45 degrees, okay? Which, if we're going to follow sig fig rules, actually you would have to round up to 50, okay? But I'm going to leave it as 45 for right now, okay? 45 degrees, it's an @ sign just like on your computer, so it's square root of 50 meters at 45 degrees north of east, okay? When you come off of the east-west line, the east and west always come second, and the north comes first, because this is north over east, north of east. Okay, you can tell by the division line, it really looks like this. Okay, that's how you had 2 vectors together. Now, I'm going to give you a second podcast, so I don't make this one too long, that deals with a more complicated D and E when these 2 are angles that you have to add together. Okay? So I hope this is helpful. Take some notes on it, have it in your notebook. If you have questions about it, make sure you ask. All right?